Welcome to the new video. In this video, we'll be talking about Chapter 8, Section 8.1, Polar Coordinates. So before starting the main discussion, let's begin something that you already probably know. Let's say we have a point in the two-dimensional space like this. So let's say this is the x-axis. This is the x-axis, this is the origin, and the y-axis, and we have a point, let's say here, and we're saying this point P is x comma y, meaning the coordinate is x, y. So how many ways we can get to this point P if we are currently at the origin O? We can go to this point in many ways, but mainly we can go here by two ways. The first one could be like this. We can go along the x-axis y unit, along the x-axis x unit, sorry, this is the x unit, and then from here we can go y direction y units. Then we can get to this point. The another way, we can start from here and we can directly go to that point. The relationship between this point you already know. If we say this is r, and the angle created here, if we say this is theta, so we can form a right triangle here. Let's say this triangle is OP, let's say this point is Q. In triangle OPQ, we can relate this x, y, and r. So if we want to relate x with r and theta, how can we relate that? So considering the trigonometric functions, the definition of trigonometric functions, we can define x over r. Since this is the acute angle, so x is the adjacent, r is the hypotenuse, and y is the opposite. So adjacent over the hypotenuse, this is defined as cosine theta. So we can write x equals to r cosine theta, and y over r equals to sine theta, that is the opposite over the hypotenuse equals to cosine sine theta. So y equals to r sine theta. And from the Pythagorean identity, we know that the x squared plus y squared equals to r squared. This is the relationship between x, y, and r. If you substitute the value of x and y right here from these two expressions, you'll get it verified. So these are the things that you already know. Now we're gonna learn something different that is new. It's called polar coordinate. The coordinate system that we discussed right now, it was invented by French mathematician and philosopher René Descartes. It's back in 1673, but later Sir Isaac Newton invented a new coordinate system. It's called polar coordinate system. It's extended to higher dimensions, but our discussion will limit our discussion up to a two-dimensional space. So a polar coordinate system consists of a fixed point and a polar axis. So let's say we have a ray like this. This is the starting point, but it has no ending point. We're saying this fixed point, this is O, and we're saying this is origin. O stands for origin, and the ray, we're calling this the polar axis. Any point in this coordinate system is represented like this. Let's say this is a point, and this polar axis rotated in counterclockwise direction, and it is stopped here. By this rotation, it created an angle of theta. So any point on this terminal side, if you say this is the terminal side or the stopping position, if you say this is P, instead of writing P of x, y like this in polar coordinate system, we write this as r theta. Now you might ask, what is this r? Well, the theta is the amount of rotation in clockwise direction, but what is r? Well, r is the distance from the origin to the stopping point, to the point P. This is defined as r, small r. So that's how we defined a point in polar coordinate system. Since r is the distance, so it's always considered as positive, but sometimes in representation of points in polar coordinate system may seem like r is negative. Let me describe those situations. So let me write this as note. If r is greater than 0, the point P is located r unit from the pole in the direction of theta. This is the first note. If theta equals to, let's say, if r equals to 0, then the point P is at the pole. Now the third node, if r is less than 0, well, r cannot be 0, but sometimes it may arise there is a negative sign before r. So in that case, the point P is absolute value of r unit apart from the pole, but in the opposite direction. That means in the direction of theta plus pi. That means opposite of, this is the other way of saying opposite of theta. So here the angle, let me draw the situation again. The angle theta, the point P r theta, this is O, I'm saying this is OX, the original axis, the polar axis, and this is the final position. So this theta is the amount of rotation. It is the amount of rotation, and theta is a directed angle from the polar axis. So as you know, the rotation could be in clockwise direction or in counterclockwise direction. So based on that, theta could be greater than 0 or theta could be less than 0. Let's do some example. So here I have a polar coordinate system. Let me increase the size. Let's say I have the graph here, and I have few points like A, first point a 3 comma pi over 4. So we have to locate this point in this graph. So here you see 3 is the distance from the pole. Let's say this is the pole, and the rotation is pi over 4. So the rotation is positive, that means we'll move counterclockwise direction. So 3 units from the center or origin, 1, 2, 3, and pi over 4 is here. So this is point A. If we have another point B, let's say B equals to -4 comma pi over 6. So in that case, since B is negative, I mean the distance, we have a negative sign before the R. So first of all, we'll consider the point without the negative sign. This is the shortcut technique, or a trick you can say. So no matter what, it is positive or negative, we'll consider with the positive sign, and then we'll adapt the negative sign. Since R equals to 4, here R equals to 4, we'll draw 4 units distance from the origin, 1, 2, 3, 4. So we are here, and then our rotation theta equals to pi over 6. So we'll go counterclockwise direction. Pi over 6 is somewhere here. So this is my point B. But now look at the actual B. Let's say this is B prime. In the actual B, we have a negative sign, so we have to come directly opposite to this direction. So right now we are in this direction, and so we have to come to the opposite direction to that point, and we have to stop at 4 units apart from the center. 1, 2, 3, 4. So this is my point B. This is the final position. You don't need to draw this point, this B prime, or the first position. You don't need to draw this. This is just for your convenience, easy to understand. One more example. Let's say we have this another point C. It's called its R is 2.5, but the amount of rotation is -4 pi over 3. So pi over 3 is equivalent to 60 degrees, and 60 times 4, 240. But since the direction of rotation is negative, that means clockwise direction. So first of all, we'll go 2.5 units apart from the origin. We'll stop here, and then we'll start moving in the clockwise direction. And if we start moving this way, we'll probably end up somewhere here, I guess. Yeah. So this is point C. I hope this helps a little bit. Let me do one more example, and the final example of this part of the video. Let's say we have another point. I'm saying this as F, -5, since negative thing is complicated kind of here. So we'll do one more example with the negative type. So 5 pi over 6. Okay, so first of all, we'll work with the positive direction. So 5 units apart from the center, 1, 2, 3, 4, 5, and then 5 pi over 6. So 5 pi over 6, as we can see, 5 pi over 6, it should be somewhere here. So 1, 2, 3, 4, 5. But as we have a negative sign here, we'll come to a straight opposite to that point, and 5 units. 1, 2, 3, 4, 5. So this is my point, the final location of the point F. I hope this helps. um, thank you for watching.